we will begin our lesson on tossing a ball in calculus by first discussing the equations that would model the position, velocity, and acceleration of the ball at any given time t. The first equation represents the position or the height of the ball at any time t. That would be given by the equation s of t equals negative 4.9 t squared plus 20t. And that would give you the height of the ball in meters at any given time t. Next, we would talk about the velocity of the ball at any given time t. That would be given by the equation v of t equals negative 4.9 times 2t plus 20. And that would tell you the velocity in meters per second at any given time t. And the final thing that we'll discuss is the acceleration of the ball due to gravity at any given time t. So that would be given by the equation a of t equals negative 4.9 times 2. Now, once we discuss these individual equations, we would also want the students to be able to relate these three equations to each other. For instance, the s of t equation, the position equation, we would want the students to graph this equation. Now, they would already have to have some prior knowledge about the graph of this equation, but they would be able to graph it either on a calculator or by hand, and they would draw a graph that looks like this, indicating the height of the ball in meters at any given time t in seconds. Then we would also want them to be able to graph the velocity function. Now, the velocity function is a line that would look like this, and they would know how to graph that line, and that would give the velocity of the ball in meters per second at any given time in seconds. And then lastly, we would ask them to graph the acceleration function, which looks like this, and it would just be very simple, a horizontal line. And that gives the acceleration of the ball at any given time t, acceleration in meters per second squared, and the time obviously is in seconds. Now, a big component of discussing the tossing of a ball or the relationship of position, velocity, acceleration is for them to be able to interpret these individual graphs. The interpretation of these graphs is very difficult unless you can put all three of these on the same graph and you can see how they would relate to each other. This is very difficult to draw on a board, on a computer. Once we realized that it would be very difficult to ask students to graph all of these separately and then try to combine them onto a single graph, what we would do would be to use this applet that I found on calculusapplets.com. Now, this applet is very, very nice because what it does is it includes the position function that we already talked about, the negative 4.9 t squared plus 20t, and its graph, as you can see right there. In addition to that, we also have the velocity function, which we talked about earlier, negative 4.9 times 2 times t plus 20, which you can see graphed there in the blue. And then you can also see the acceleration function over here on the right, which is given by negative 4.9 times 2. And you can see that that is the horizontal line in the red there. Now, all three of these have been graphed on the same graph here. And as well, on the left, you can see a little meter that goes vertically, which is basically a picture of the ball. You can see that black dot, that's representing the ball. Now, what we can do is we have a couple different options with this applet. I can choose start. And what you can see is that on the left side, the ball travels up and then back down as if it were being thrown into the air. And then I have it set to loop, so it would keep going over and over. Now, at the start, the ball is on the ground. When you hit start, you see that it gets tossed up in the air. It reaches a height of about 20 meters, and then it comes back down to the ground. And then I have the applet start over, so it gets tossed up again, reaches 20 meters, and then comes back down. Now, obviously, everyone understands when you throw a ball up, it's going to go up and it's going to come back down. But what we want our calculus students to understand is how the graphs of position, velocity, and acceleration are going to relate to each other and to this particular situation. So, a couple things, all right? You see the position graph here, and you can see the little plus sign moving along it as time goes on. Now, you can see very easily, if I move back in time here, you can see that at about this location right here, you can see that the plus sign seems to be at the top of that. If this looks kind of like a hill, you can see that the plus sign is on top of the hill. You can also see on the left side that it seems as though that is the maximum height of the ball, meaning it reaches a height a little above 20 meters. Now, what we would want our students to do is to be able to relate the fact that the ball is at its maximum height. And now if we look down to velocity, well, what is the velocity? Well, it looks like it's very, very close to 0. It's on the x-axis. So we would want our students to be able to relate those two things. Then we go down to our acceleration, and you see, well, the acceleration is always along this red line, which is a horizontal line. Now, we would refer to that as a constant function, meaning the acceleration is always the same. And if we understand anything about physics, we know that the acceleration on Earth due to gravity is constant. It's always the same. Now, we would continue to play, and we would want our students to realize that, let's say at this point, let's let it go a little bit further, and I will pause it somewhere around here, where you can see at this moment, the ball would have already traveled up, reached its maximum height, and then now it's traveling back downwards. Now, at this time, when the ball is traveling downwards, we would want our students to notice that the velocity now is below the x-axis, so it is less than 0, meaning the velocity is negative, meaning you're traveling downwards. Once again, the acceleration is the same, always the same. So, after allowing our students to view this applet and talk about the significant points that we did and the relationships between the two, we would then be able to ask them a few questions regarding this example.